Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to Part 4 of Advanced Threat Tactics, Post-Exploitation. So far, we've worked to stand up our infrastructure and get a foothold in a modern enterprise environment. Now, we're going to continue that by conducting post-exploitation on the systems we've compromised so far. We're going to talk about how to manage and use Cobalt Strike's beacon payload. I'm going to show you how to pass sessions with beacon. We'll talk about file system browsing and manipulation with beacon. So that's basically how to download and upload files. We'll talk about user exploitation, logging keystrokes, and taking screenshots. I will also take you through browser pivoting, which is a very unique Cobalt Strike only technique. And we'll talk about port scanning as well. So how do you interact with beacon? Well, right-click on a beacon session, go to interact, and this will open the beacon console. In the beacon console, you can see when the beacon last checked in, the user the beacon is running as, the process ID, and the computer name as well. The beacon console will also show you the commands issued by your teammates and output from their commands. Any commands issued by somebody else other than you will show up with their name before the command. Now, when you interact with the beacon, you can right-click in the beacon console or on the beacon session and choose one of these menus, okay? The access menu are options to manipulate trust relationships and elevate your privileges. The Explore menu are options to control the target and spy on the user. The Pivoting menu are options to tunnel traffic through this beacon. And the Session menu are options to manage this particular session. One of the most important commands in Beacon, because I cannot cover all of them in this video, is help. Type help to get a list of the commands in Beacon, and to get help for a particular command, just type help in the command name. This information is always up to date with the latest things that you can do with the beacon payload. Something else you're going to want to know how to do. You're going to want to know how to change the sleep time for your beacon. You can do that with the sleep command. Type sleep 30 to make the beacon sleep for 30 seconds in between attempts to call home. You can also specify a jitter factor. Just do sleep 60, 50 in this case, and that will set the sleep time to 60 seconds with a 50% randomization, meaning the beacon's going to call home between 30 and 60 seconds each time. To run a command in the Windows command shell and get output, type shell and whatever command and arguments you want to run. This will tell Beacon to spawn a command shell, run what you asked, and provide the output back to you. Now, the shell command will always run from the current working directory of the beacon, okay? If you want to change that working directory, do not do shell cd some folder, because that will spawn a new process, change its directory, and close it down. Instead, use Beacon's cd command. Just do cd and whatever folder you want to go to, okay? Now, if you want to check which directory is the current working directory for Beacon, just do pwd, which is print working directory, and when Beacon checks in next, it'll tell you which folder it's currently operating from. You can also use PowerShell through Beacon, okay? First, you can just do PowerShell, whatever commandlet and arguments you want, and Beacon will run PowerShell, run what you asked, and report the output back to you, okay? Now, if you have a favorite offensive PowerShell script, you can use it with Beacon as well. Just do PowerShell-import and give Beacon the local path on your system to that PowerShell script. Cobalt Strike will import that script into memory inside of that beacon. Now, future runs of the PowerShell command can reference commandlets in that imported script. This allows you to seamlessly take advantage of different offensive PowerShell capability that's available in the open source world, plus your own custom stuff. Now, when you're using PowerShell, if you want to get help for a commandlet, do PowerShell get help, the commandlet, followed by -full. Most PowerShell commandlets are documented in such a way to work with this convention, and this will give you back information on how to use that particular PowerShell commandlet. Okay, let's take a look at basic beacon management. Here we are in Cobalt Strike, and I have several systems calling back, okay? About 6. What I'm going to do is I'm going to pick one of these, right-click, go to Interact. This is the beacon console, okay? We can see when the beacon last checked in, the process ID, the username we're running as, and the computer's NetBIOS name. Same information available up here, okay? Cool. If you right-click in the console or right-click on a beacon, this is the beacon menu. So here in the Access menu, these are our options to establish trust relationships and elevate our privileges. These are options to explore the system, options for tunneling, session passing, and controlling our access. What I'm going to do right now is tell all of these beacons to sleep for something other than 60 seconds. I'm going to put all of them for now on a 5-second interval. Okay? So I've just tasked all of these beacons en masse. And this one is going to check in about 5, 4, 3, 2, 1, check in. There we go. Okay, so let's take a look at some basic things. First, the help command in beacon is your best friend. This command lists all the different things you can do with a beacon. It's an ever-growing list. And you can type help and a command name to get help for that specific command. Now let's do some beacon basics. PWD will print the current working directory and tell you where you're at. If you want to change the directory in beacon, just put in the folder you want to go to, and then you can do things from that folder. Like if I do shell space dir, this will actually produce a directory listing from the Windows command shell in this folder. Okay? As easy as that. Next thing I'd like to show you is PowerShell. You can use beacon to run PowerShell strings if you want, or PowerShell commandlets. So here, PowerShell 2 plus 2 gives us back the value of 4. Okay? So you can use PowerShell through beacon just as if you were sitting on that computer as well. Now, let's talk about session passing. Beacon was originally designed as a low and slow placeholder to spawn Meterpreter sessions as needed. It wasn't meant to be a post-exploitation agent. But one thing Beacon was always good at from day one was session passing. If you right-click on a beacon and go to spawn, you can choose a listener from any of the team servers you're connected to and task Beacon to create a process and inject the stager for that particular listener into that process. And that is how you pass sessions with Beacon. You can also inject a listener into a specific process. Just do inject, the process ID, and the listener name. Okay? And session passing works with both beacons on other team servers and foreign listeners as well. Let's take a look at session passing with Cobalt Strike. Session passing is easy when you're connected to multiple team servers. Let's go to our localhost team server and create a listener for an HTTP beacon on port 80. Okay? Now, let's pass an access to this team server. Just come over here to the server with all the accesses, go right-click, spawn, choose the listener you want to pass an access to. You'll notice when you're connected to multiple team servers, Cobalt Strike pools the listeners from all of your servers. Press choose, and as those beacons check in, new accesses will show up over here. Okay? So that's session passing with Cobalt Strike. Now, let's say you want to pass a session to a friend using the Metasploit framework. You can do that. Let's come over here and let's open up a terminal and start the Metasploit framework console. Okay? And what we're going to do is create a handler for the Meterpreter payload. So let's do set payload, Windows Meterpreter, reverse HTTPS. Let's set L port to 443 and L host to 192.168.1.2. And let's go ahead and kick that off. Cool. We now have an HTTPS Meterpreter handler running on this host. Let's pass some accesses to the Metasploit framework. First, we need to create a foreign listener. So let's go press add. And we're going to call this Rafi's Meterp HTTPS. And we're going to use a foreign listener, which is an alias, basically. We're going to point that to 192.168.1.2.443. Cool. Press save, and we now have a foreign listener. Now, let's go ahead and pass some accesses to the Metasploit framework. Okay? So let's go ahead and pass right-click spawn, and we'll pass our What a Hog on this Windows 10 system over. And when this beacon checks in next, we get a Meterpreter session. Okay, let's talk about working with the file system through Beacon. One way to do that is through the file browser. If you right-click on a beacon, go to Explore, Browse Files, you'll get a file browser very similar to the one in Armitage. Now, the file browser will allow you to navigate through folders, upload files, list drives, download files, and delete files as well. One thing I want to point out, each time you do something in the file browser, it will create a task for the beacon to execute. If the beacon is calling back low and slow, the file browser will not act on what you've asked until the beacon checks in. It simply can't. It's impossible. So it's best to use the file browser with a beacon that's sped up to be interactive or have an otherwise very low sleep time. Beacon does some really interesting things when it comes to file downloads. You can use the file browser to tell Beacon to download a file, or you can use the download command to request that a file is downloaded as well. Now, Beacon does not exfiltrate a file in one big chunk. Instead, Beacon is designed to drip a file out of a network. How does it do that? Well, each check-in, Beacon will grab a small piece of all the files that you've asked it to download. So each check-in, it'll download parts of the files. So if Beacon is set up to check in quite often, maybe every 1 to 2 seconds, you'll get the file pretty quickly. If Beacon is set up to sleep for a long time between check-ins, maybe once every minute, minute and a half, or every hour, you will get the file out very, very slowly. The nice thing, though, is you can tailor exfiltration to whatever the needs of your environment are. If you want to cancel a file download, you can do that with the cancel command. And the cancel command accepts wildcards as well. So you can do cancel star to tell Beacon to cancel all in-progress downloads. If you want to see which downloads are in progress, type downloads in the Beacon console, and you will get a list of the downloads that are currently in progress and where they are at in their journey. Now, files are downloaded to the team server, okay? To access those files, go to View, Downloads. Downloads that are complete will list in this tab. Now, all you have to do is highlight the file you want to interact with and press Sync Files. Cobalt Strike will then ask you for a local folder to dump those files to, and it will download those files from the team server and put them on your local system for your enjoyment. Use the upload command to upload a file through Beacon, okay? When you upload a file, Beacon will keep track of the MD5 hash of the file and make that available in its reporting. It will also note the MD5 hash of that file in its logs. Now, if you need to, you can use the timestamp command to change the timestamps of the file you uploaded. Just do timestamp, the file you want to update, and the file that you want to pull timestamp information from. This is a great way to make any persistence you install blend in. Okay, let's take a look at file exfiltration with Cobalt Strike. I'm going to interact with a beacon for Jim Stevens, and I'm going to put this beacon on a 5-second sleep interval. Now, let's go to Explore, File Browser, and this is Beacon's file browser. Let's ask it to go up a folder. Now, each command I give it is only going to take effect once the beacon checks in, okay? So if you have a high sleep time, you're going to have to be pretty patient with the file browser. Double-click the users folder. Let's go to Jim Stevens. There we go. And let's go to Documents. And I see a file that looks interesting to me, transactions.csv. Let's go ahead and right-click and ask Beacon to download it. When Beacon downloads files, it downloads them one chunk per check-in, okay? So you can ask Beacon to check in more often and get the file faster, or you can keep Beacon on a low and slow interval, and it will pull the file out very, very slowly. So here, we're downloading this transactions file. Now, if you want to know the progress of the download, just type downloads, and there we go. We can see we've grabbed about 2 megabytes of it so far. Let's go ahead and speed this up to a 1-second interval. And now we should grab the file a little bit faster. And so we should be getting about 0.5 megabyte per transaction. If we want to check the status, we can see we're there. We've now grabbed the transactions.csv file from this host. The file is stored on the team server. If you want to grab it, go to View, Downloads, okay? And to bring that file to your local system, just highlight it, press Sync Files, and tell Cobalt Strike where to store it. And there's the file being downloaded from the team server to our local file system, okay? So that's an example of exfiltrating data with Cobalt Strike. Okay, let's talk about user exploitation. Cobalt Strike does a really good job with user exploitation at scale, and you'll see that here in a few moments. First, let's talk about jobs. Beacon tasks run as jobs. The keystroke logger, PowerShell scripts, commands, the screenshot tool, the port scanner, most post-exploitation features in Cobalt Strike, by design, are injected into another process, and they feed information back to Cobalt Strike's beacon over a named pipe. Now, to see a list of jobs in a beacon, just type jobs in that beacon's console. And if you want to stop a job early, type job kill in the job ID, and that will give Beacon a task to shut down that job for you. Let's talk about user exploitation. Cobalt Strike's screenshot tool injects into a process of your choosing. It can be a 32-bit or a 64-bit process, and takes screenshots, one per check-in, for as long as you specify, okay? So to inject the screenshot tool in the process, just do screenshot, the process ID, give it the architecture, and specify how long you want to keep taking screenshots for. Optionally, you can leave the time out and the screenshot tool will just take one screenshot. The keystroke logger is similar. You can do keylogger, the desired process ID, and tell it to inject into a 32-bit or 64-bit process. The keystroke logger will then run as a job in that process and report keystrokes back to you. Now, if you want to view the results of either of these tools, go to View Screenshots to see all the screenshots reported from all of your beacons, or View Keystrokes to see all the keystrokes reported from all of your beacons. Now, one thing you're going to find is if you're trying to type screenshot and keylogger to deploy those tools, it becomes very tedious to deploy those across a large number of systems. Don't worry, Cobalt Strike is here to help you. Highlight all of your different beacon sessions, either in the table view or pivot graph. Right-click, go to Explore, Show Processes. Cobalt Strike will open up a dialog where it collects all the reported process information for all of the sessions you highlighted. Okay? What you can do from this perspective is sort those processes by name. Then you can highlight all of the Explorer processes on all these sessions and deploy the screenshot tool or keystroke logger to all of them at once through this particular dialog. So this is Cobalt Strike's model for user exploitation at scale. Okay, let's take a look at Cobalt Strike's user exploitation features. Okay, so here we have 6 systems beaconing back. Okay, now let's say we want to start gathering screenshots and understanding what's happening on these systems. We can do that. First, I'm going to close these beacon consoles, close that file browser, and I'm going to right-click, go to Explore, Process List. Okay, this is going to dump processes for all these beacons as they check in. Okay, so you can see external, internal, so on and so forth. If I didn't want to do all the beacons, if I just want to do select beacons, I could hold down Control and Alt and select and deselect individual beacons. So now we've got a list of a bunch of processes. What use is that? Well, let's sort by name. Let's come over here to explorer.exe. And now we're in a position to actually deploy a keystroke logger and a screenshot tool to all of these different systems. So let's do log keystrokes. And as easy as that, it takes care of the dirty work of picking the architecture and deploying the keystroke logger. And let's deploy the screenshot tool. So we'll just go screenshot and we'll have it take a screenshot for the next 15 minutes. So every check-in, we'll get new screenshots. Cool. Now let's go to View, Screenshots. And this is where screenshots will show up as they come in. And View, Keystrokes. And this is where keystrokes will show up as they come in. You can see we're getting these every check-in. Let's just go ahead and make that a little smaller. And so this is the activity happening on each of those systems. And let's sort that so the latest screenshots are at the top. Okay. So you can see this makes it real easy to monitor on many different systems for activity. Now this feature is a little nicer if you have these beacons calling back a little bit slower than every 5 to 10 seconds. So let's slow these beacons down. Okay, so now they're going to call back between 15 and 30 seconds. But again, really nice. You can just quickly scroll through and see what's going on these different systems. Okay, so that's the screenshot tool. Okay, let's talk about browser pivoting. Browser pivoting is a man-in-the-browser attack to perform session hijacking against websites that your target is already interacting with. Here's how it works. You inject the Browser Pivot agent into the target's Internet Explorer process. This is an Internet Explorer only technology. Cobalt Strike will create a web proxy server on the team server for you, the attacker, to point your browser to. Okay? Anything that goes through that proxy server on the team server will be sent to the browser pivoting agent to act on. The browser pivoting agent will get Internet Explorer to fulfill the request, and even better, Internet Explorer, when it fulfills the request, will automatically insert the user's authentication material into that request. Meaning, if the user is logged into facebook.com and you go to facebook.com through the browser pivot, the user's browser will fulfill those requests for you, and you will be logged into facebook.com as that user. Okay? Browser pivoting takes advantage of the way Internet Explorer is architected and the way it does storage of credential material and reauthentication. This inheriting of credentials works for NTLM authentication, it works for session cookies, it works for cookies in general, actually. It also works for any client SSL certificates as well. Okay, let's demonstrate browser pivoting. Let's say you're flipping through the different screenshots that Beacon is feeding back to you, and you come across a user interacting with a web application that you want access to. If they're using Internet Explorer, you can use browser pivoting to get into that same application as that user. Here's how that works. First, interact with that beacon. Go right-click, Explore, Browser Pivot. Now we have to wait for the beacon to check in before it actually gives us the information. Now what we want to do is inject the Browser Pivot agent into Internet Explorer, but not just any Internet Explorer process will do. We need to inject into a child tab process, not the graphical shell that was launched by Explorer. The check mark indicates a Internet Explorer process that is a good candidate to inject into. So let's go ahead and inject, and we'll put the Browser Pivot proxy server on port 1080, hit launch, and there we go. Any traffic that goes through this HTTP proxy will come out the user's browser or the target's browser authenticated as them. All right, let's go ahead and open up Iceweasel. And let's surf over to 192.168.1.95/roundcube. You'll notice we're given a login prompt. That's because we're just trying to go to this mail server on our own. Now let's try to go to this mail server through the Browser Pivot proxy server. So the Browser Pivot proxy server is on the team server, which in this case is ads.losenolove.com on port 1080. So let's go ahead and set that, hit refresh, and here we are. We're in the user's web application as them, and we can read their email and do all kinds of fun things as them through this application. Okay? We can even compose messages if we want and go phishing directly from somebody else's account. Nothing quite like an email from your boss to get the user to take the action you want. So that's browser pivoting. A couple of things to know. Browser pivoting does work with SSL secured sites. You will be prompted to accept the SSL cert for Cobalt Strike's web proxy server. So make sure you just hit add an exception when you go to an SSL site. Look inside the Browser Pivot console, and if you see it tell you to add a site to trusted host, go ahead and do that. Okay, let's talk about port scanning. One of the cool things about Cobalt Strike's model of offense is that everything happens through the beacon payload. If you're using Cobalt Strike right, you're not going to sit back in the conference room and run a port scanner to discover targets or tunnel a port scanner through a beacon. Instead, you're going to deploy a post-exploitation capability to a beacon, and beacon is going to execute that action on your behalf in between check-ins. And that's how this port scan module is designed. The port scan module scans whatever hosts and ports you like, okay? So it works just like you would expect a port scanner to work. You can specify a range of hosts. You can comma separate multiple range of hosts if you like. You can use an actual range or CIDR notation if you like. Same thing with ports. You can specify ports as ranges. You can specify individual ports, and you can comma separate them as well. The port scanner built into Beacon has 3 different methods to check if a host is alive before it scans it. It can use ARP to actually check if a host is alive. It can use an ICMP ping, or it can just assume that all hosts in the specified range are alive and try to scan them anyways. One thing to note is that the port scanner module in Beacon is designed to use asynchronous I/O to perform the scanning. So it doesn't create threads for each individual scanning action. This is kind of cool because in Windows 7 and later, you can actually have a very large number of sockets open at once, making the scanning process very fast if you choose to do so. So the max option is your option to specify the max number of sockets the port scanner should work with in its working set at one time. I recommend using 4 for Windows XP, and for Windows 7 and later, you can use a large number and go pretty much as noisy as you want. Just be aware that if you set this number too high, you might end up losing results. So it's best to keep it something sane, and 1024 on 7 and later is a good default. Let's take a look at the port scanning tool in Beacon. Here we are on our localhost team server with a beacon calling home every 10 to 15 seconds. Okay? To kick off the port scanner, just go right-click, Explore, Port Scan. When this beacon checks in next, it will give us a list of networks that we can deploy the port scanner against. So let's go ahead and do 10.10.10.0 with this subnet mask. And we can give it a list of ports. We can tell it how to discover hosts. And the max number of open sockets it should have at any one time. This default configuration looks good. Let's go ahead and hit scan. And away we go. When the beacon checks in next, it will take the port scanner module, inject it into another process, and feed the host and service information back to us over time. This module updates Cobalt Strike's targets data model under View Targets. Okay? That's this information right here. It's also the same thing you see if you come over here with the little target icon. So every time Beacon checks in, it will read in some more information from the port scanner. So the port scanner module will run in between Beacon check-ins. So let's give this a few minutes to run because we have to wait for the check-ins to occur. What we'll do, I'll come over here to the data model. So as targets become known and get added to the data model, we can see this update. Okay, it looks like our scanner module is complete. And a few things I'd like to point out. You can see over time we received different output. In the case of some services, the scanner module does banner grabbing, and it uses that information to try to guess the operating system of the discovered target. It also can do some SMB version-like activity to try to figure out from port 445 the version of the operating system, the NetBIOS name, and the domain that it belongs to. Okay, so pretty cool stuff. If you highlight these hosts in the target model and go to services, you can see the different services that were discovered as well. Okay, and so you see the banners, and you can also assign a note to the different services if you want to. So that's a little bit on the port scanner tool in Beacon. Okay, in this lecture, we talked about post-exploitation with Cobalt Strike's Beacon payload. I took you through some basic concepts to manage your Beacon sessions. We talked about session passing. I showed you how to upload, download, and browse files. We talked about Cobalt Strike's model for user exploitation at scale. We also went through browser pivoting, and I showed you how to discover targets with Beacon's port scanner module. This concludes part 4 of Advanced Threat Tactics.